Welcome to EDU World Space.
Hi, in the given problem, the time period of oscillating particle is given as 0.900 second and its amplitude is 0.320 meter. It is said that at a time t is equal to 0, the particle is having a displacement x is equal to 0.320 meter, means the particle is at its extreme position at a time t is equal to 0 and instantaneously it is at rest, means the particle is having an initial phase difference of pi by 2 from its mean position. So its equation may be given as x is equal to a sine, its instantaneous displacement x is equal to a sine omega t plus phi. So for a, this is 0.320 sine. For omega, this is 2 pi by t into t plus phi. Or we can say 0.320 sine 2 pi by 0.9 into t plus pi by 2, the initial phase difference, which is clear from the given condition. Hence, the equation of this oscillating particle comes out to be 0.320 meter cos 2 pi by t, means 0.90 into t. Or we can say this is 0.320 meter into cos 20 pi by 9 into t. This is the equation of the given particle, the oscillating particle. Now, in the first part of the problem, we have to find the time taken by the particle to come back from the position 0.320 meter to 0.160 meter. Means the instantaneous displacement for that time means x is 0.160 meter is equal to 0.320 meter into cosine of 20 pi by 9 into t1. Let it be t1 this time. So cos 20 pi by 9 t1 will become 0.160 meter divided by 0.320 meter, which comes out to be 1 by 2. And we know 1 by 2 is the cosine of angle 60 degree, which can be written as pi by 3. Hence, comparing these two sides, left hand side and right hand side, as the angles are same, so we can write 20 pi by 9 t1 is equal to pi by 3. So cancelling this pi, the time taken by the particle to come back from 0.320 meter to 0.160 meter will be given by 1 by 3 into 9 by 20. Here 3 3s are, and this is in second. So this time t1 here comes out to be 3 by 20 seconds, or we can say this is 0.15 seconds. So the particle will take 0.15 seconds to come back from the position 0.320 meter to a position 0.160 meter, and this is the answer for the first part of the problem. Now, in the second part of the problem, we have to find the time taken by the particle to come back from this 0.160 meter to x equals to 0. So, first of all, what will we do? We will find the total time taken by the particle to come from 0.320 meter to mean position. So, again, for which we will use the equation x equals to a cos 20 pi by 9 into, let the time be t2. X here is 0, as the particle has to come back to the mean position. A 0.320 meter into cosine of 20 pi by 9 t2. So we can say cos 20 pi by 9 t2 is equal to 0, which is the cosine of angle 90 degree, which can be written as pi by 2 radian also. So this 20 pi by 9 t2 here may be written as pi by 2. Then cancelling this pi, the time taken by the particle to come back from 0.320 meter to the mean position comes out to be 1 by 2 into 9 by 20 seconds, or we can say this is 0.225 seconds. Hence, time taken by the particle to come back from 0.160 meter to the mean position will be this total time t2 minus the time taken by the particle to come back from 0.320 meter to 0.160 meter, means this is 0.225 minus 0.15 seconds, which comes out to be 0.075 second. And this is the answer for the second part of the problem. Moreover, if we want to explain it in the form of a diagram, here this is the mean position, let it be O. This is the extreme position at which initially the particle is supposed to be present. So here this distance is given as 0.320 meter. Now the particle takes a time t1 to come back to this point C, which is 0.160 meter, and then it takes time delta t to come back from C to O. So this is the answer for the given problem. Thank you.